If previously we discussed on soil fauna, now we discuss on Oligochaeta, the earthworm. Okay, this is one of the organisms that for me is very important in soil ecosystems, and usually it should be embraced by human, especially for the farmers, especially for the person who deal with the agriculture. So. For me, earthworm is a very important organisms, and let's look how their function, their roles and their functions in the soil ecosystem. Okay, sorry. So basically, I'm not discuss into detail about the distribution, the biology, and ecology. I think this you can find in different type of lecture, different type of course. But I want to focus on the influence on soil process and also the management of in for this species for this family of Oligochaeta, or the earthworm. So you can find about the distribution of biology and also some of the sampling and identification in the textbook, and also you can find in different lecture that will focus mainly on this earthworm. But I will focus on the influence on soil process and also the earthworm management. So a little bit some brief introduction. So I think earthworm is somehow is an organism that all like what Darwin said in his book talking about is doubted whether there are many other animals which have played so important a part in the history of the world as have these lowly organized creatures. So this is something that shows that how uh, even when we're talking about evolution of the organisms, we're talking about the how these organisms is very important, and how the organization of these organisms in the soil especially influence the ecosystem as the whole, especially for the other organisms, and also the balance uh, in the ecosystem. Sometimes I'll focus on the soil, but I think earthworm play more roles, not only in the soil but also in the ecosystem as a whole. Okay, when we talk about where we can find the earthworm. Of course, we can find that they can find worldwide. They can be found everywhere, where especially when the soil and water and the temperature is favorable, at least for the part for the part of the year. Okay, and then of course they display a wide array of physiological and behavioral adaptations, so especially to the environment conditions, so which means that they can inhabit any local microsites in the world, so saying that they have this capability to adapt to any environment. That's why we can find this earthworm almost everywhere. So especially during a unfavorable condition, they can become dormant. So that's how they adapt, and that's why they can be found in the temperate and also in the tropical area. So they can be found in basically any parts of the world. Okay, of course, uh, in for the salt I like this what this author, the Blackmore, talk about, gave a remark about the earthworm. They talk about people who loves or admire birds. The bird watcher always always try to look at the bird life and everything, but for the if you look down and if you look at the soil, you can find that every hundreds of kilograms per hectare of live soil in pasture almost totally ignored an underground biomass of earthworm, so often far in excess of those above, that may a total of 2 or 3 tons per hectare. So bird watchers, you can see birds upstairs, but if you look downstairs, you can find tons of earthworm in the soil. This is how he tried to make a clear statement on the abundance of earthworm in the soil. So intensive land management, of course, in the application of soil tillage, in the application of the chemical, they significantly reduce the density of the earthworm, and of course they degraded the converted conservation management. So, people who do less chemical, do less tillage, will have a lot of earthworm uh, in the soil. So we will discuss about this conventional and non-conventional talk about ecological agroecological techniques in agriculture. So how it impacts, especially in terms of organisms and in terms of earthworm, in our discussion later on. Okay, but bear in mind that our land management, our practices in agriculture can increase the population of earthworm. So we can see that here, different types of habitat can have different types of different density of earthworm. Okay, from the temperate hardwood to the arable soil. Okay, in terms of biology, they are very soft. They are soft body. They have segmented animal. They have segmented, so they have a ranging of length. So for those who always, I myself, when I grew up, I always try to find earthworm for me to go before I go fishing. So I use earthworm as bait. Never in my life I found this kind of big earthworm. Never in my life. Of course, not like this, and of course, I will not attempt to do this. Okay, but in so somebody will have to switch to this picture. So some of course, this it means that the different types of uh, we can find different types of uh, earthworm in terms of morphology in the different parts of the world. Probably Malaysia have the very small, tiny organism because of they don't need to grow big like this. Okay, but anyway, this is something that you can look at it, which means that they are different type of body. Okay, of course, no, I will not attempt this. Okay, fast forward. Okay, anyway, the earthworm can be characterized based on their ecological strategies. Of course, there's endozoic, epizoic, and anasic. You can look at what the differentiate between this, and of course, some of like especially the endozoic earthworm, they have subcategories like a polyhumic, oligohumic, and mesohumic. So these are different types of how they function, or how their ecological strategies, if I can repeat that, determine different types of organism, different type of earthworm in the soil. Okay, so these are the characteristics about the habitat, how what they are feed, and then also their size. Okay, there's differences between epizoic, endozoic, and anasic earthworm. So for those who are interested to go further in the earthworm study, I think you need to understand what is difference between epizoic, endozoic, and anasic. Okay, of course, when talk about earthworm, already stressed about this over and over again about the earthworm as the ecosystem engineers. There are two functions, or there are two roles, or there are two ways of how earthworm can become the engineers, or the ecosystem engineers in the soil. First, because their capability of burrowing activities, because they can dig, and then they can create holes. And another one is the ingestion of soil and produce the castings. Okay, production of the casting of the earthworm, because they ingest the mineral soil, and also when you can read here particular organic matter, and then when the the digestion of these materials, they can mix them together, enrich them, and they produce the cast. The cast is very high in minerals, in nutrients, as they say. So, of course, during the formation of this earthworm casting, uh, microbes will play some important roles in terms of colonizing it and try to break down for the soil organic matter. So as cars deposited into the soil, so micro, colonization of microbes uh, continues and can be ready in terms of decomposition process in other places. So kind of like the earthworm put the microbes in the soil, separate the microbes using the cast. So of course, eventually the cast may harden. They can be hard and become stable and then become a stable soil aggregates. So this mechanism of cast solubility include organic bonding of the particles, secreted by the earthworm and microbes, and become the mechanical stabilization of the plants. So usually earthworm casts have a very enriched plant available nutrients, which this can enhance soil fertility and also enhance plant growth promoting substance. So this is something that really important. So that's why some of the studies has using this mechanism to do to do vermicomposting. So how they want to compose leaf litter or compose the organic matter. So they use earthworm using the process called vermicomposting, using earthworm as part of it. Okay, I'll talk about it a bit later. Okay, so of course you can look at all this structure about the how they this epigeic anesthetic, so energetic, uh, where's epigeic, epigeic, energetic, and anesthetic type of um, activities, type of the activities by these types of these characteristics of earthworm in terms of external, and then you can look at all the internals, how they mature the digestion. So these activities, the burrowing activities, and also the mutualistic digestion here plays important role in the agriculture, or at least for the importance for the for the crops or for the plants itself. Uh, okay, so however, in fact we've discussed a lot of importance of the earthworm. There's some bad uh, impacts or some aspect that of the earthworm we consider as undesirable. Okay, so they have to some include, okay, we can have they listed here. Some of detrimental effect include removing and burying of surface residues that would otherwise protect soil surface from erosion. So they probably make uh, cracks, right? So they also the process can produce about the digging and the burrowing can cause the soil erosion. How much degree, it depends on area and uh, it depends on area and situation. Okay, they also producing fresh cast that increase erosion and surface sealing. Of course, it is increasing compacting of surface soils. That is what we discussed before. Depositing castings on the surface of lawns and golf greens where there are nuisance. So some people hate the casting. So dispersing weed species, the weed seeds. So this is something that a little bit because they eat weed seeds in the soil, and because they cannot digest them, and then they distribute this casting with weed seeds to other areas and become so the weed problems in another area. Also, some of them can transmit plant or animal pathogens, uh, riddling irrigation ditches, making them less able to carry water, increasing losses of soil nitrogen through leaching and nitrification, and increasing soil carbon loss through enhanced microbial respiration. There have also been reports of earthworm transmitted pathogens, either as passive carriers or intermediate hosts. So these are some of the detrimental uh, effects. So like this one, see, golfers will hate these castings. They cannot make a direct putt to the hole, right? That's why they hate it. So you can look at how big the casting and how big the ball, the golf balls here. So that of course they make it. So for you golfers, for non-golfers like me, I feel like this is okay. But for the golfers, so that's why they have some they try to reduce the population of earthworm in the golf course. So which means that golf course you cannot grow anything out in there theoretically. Okay, so I don't know. We need to study of that. But however, this is the net result of the positive and negative effect on earthworm. Okay, so you can look at this net effect, both negative and positive. To be honest, is kind of like the negative effect for the human benefit. We can say this, or I can say almost negligible. It's too many benefit. If we remove earthworm in the soil, the impact, the the negative impact, especially to our benefit, will reduce dramatically. Will increase dramatically the negative impact, and of course in the ecosystem as a whole, especially in the soil system. Remember that they are burrowing. What's the importance of this burrowing activities? We have using pores, how to nematodes, how the microarthropods, other organisms want to move if we don't have these tunnels made by the earthworm. So that's one of tiny bits of things that importance played by the uh, earthworm. Okay, so we need to a little bit be logic about their function. So we need to have this pro and cons. So I think more pros than the cons. So of course, we talk about. I really like to re-stress again about the vermicomposting. This is something that uh, I really admire for those who like to do composting. So you can put earthworm in there, and then you can see that they can expedite the process of composting. At the same time, they also can produce a good nutrients, because they have a lot of microbes, the indigestion, the production of casting. Then they can make a very good high quality compost. Of course, some of because of this potential of to increase nutrient, to increase fertility to the soil. Sometimes earthworm has been used to reclimate, to rejuvenate uh, the unfertile soils. They just put they just put earthworm inside to the soil to make sure that then they leave it, and then let the earthworm do the work, and finally they can make a good fertile soil after few years. This is how they some of the farmers try to imitate, try to replicate, try to do to especially to increase the soil fertility, because once you put the earthworm there, they will create a good environment, not only for the plant itself, not only for the earthworm itself, not only for the soil itself, but the whole ecosystems, especially the one that give benefit to the plants, to the crops. And finally, probably I will talk about some of the ways to do the sampling of the earthworm, and how, and then of course the identification. So the most popular one is of course the hand digging, soil sorting. So there are so some of the using traps, using pitfall, using some of the trapping. There's of course there's some weaknesses. We can look at the uh, in the textbook about what kind of the traps and how they are not very suitable for the earthworm. But some of the researchers are using it. Depends on the objective of the study. They use a grunting as one of the mechanical. They try to hit this. They try to use vibration to make sure that they can make this the earthworm go outside from the ground. Okay, sometimes they also use electrical. The most popular one after hand digging is also, of course, using the chemical irritants. The mustard powder slurry is one of the most popular one, and of course, for indirect one, using the cast counting, they try to how they want to know how the density of the density of the earthworm based on the number of the casts that they can found. Okay, so that's all for the earthworm.